Assalamu alaikum students, how are you? I hope you are fine and you are doing well in logarithms. Today we discuss another new thing, that is anti-logarithm. As we already learned in the history of logarithm, that is the Jos Berge is the inventor of the tables of anti-logarithm. So we relate our value of anti-logarithm to these tables when we use scientific calculator to find. In this regard, we do the question number 3 of exercise 3.2. In this, we are required to find out the numbers whose common logarithms are given. We are given two different parts. In one, 3.5621 logarithm is given. We do not know the number whose logarithm is that, as well as 1 bar 0.7427. For it, we also required the number. For this, we have to learn what is anti-logarithm. So let's discuss. Anti-logarithm, that is the number whose logarithm is given is called anti-logarithm. I hope that is very easy to memorize, but symbolically we write as, that is, if log y to the base a is equal to x, then y is anti-logarithm of x. Then y is anti-logarithm of x. Symbolically, we can write as y is equal to anti-log of x. That is the basic concept of anti-logarithm. If we recall the use of tables of logarithm, the same kind of phenomena is also used in the tables of anti-logarithm for common log when base is 10. But there is a little difference. For tables of logarithm, we use first four significant digits, but in this we use the first four decimal place values to find out the anti-log. First two values are considered as hours, third is as minutes, and fourth is as second. Hours, 74 hours, 2 minutes, and second. If you want to use anti-log tables, you can carry on as same way as you are told in the lecture to find the logarithm of a real number. You can watch that lecture and recall that phenomena, how to use the log tables, and you can use the anti-log table in the similar way. But as we use scientific calculator to find out the values of the unknown numbers for whose logarithms are given, so let's do the part 1. Part 1, in which we are given the number 3.5621. Let the required number be y. That means we are given log y is equal to 3.5621. According to the definition of anti-logarithm, if log y, as this is common logarithm base 10, we do not write it. If log y is equal to x, then y is equal to anti-log of x. So it means taking anti-log of both sides, we have y is equal to anti-log 3.5621. We use calculator to find the anti-logarithm of 3.5621 like. As we are required to find out the numbers whose logarithm is given, so we use the anti-logarithm function. For this, we press the shift button first and then we press the function of log. We observe on display screen the 10 raised to power. Put the value of the logarithm in the power whose number is required, and in that case 3.5621, and then press equal. We'll get 3648.379443 in display screen. And we get the value 3648.379443 on the display of the screen. According to tables of anti-logarithm, we have to keep our value up to first four significant digits, and that is 3648. And if we round our value, that remains 3648, but in tables we find the value 3649, a minor variation due to the value near to half. So hence, as value is more than 48, therefore we can write as 3649. But if we retain these four significant digits, 3648, then the answer is acceptable. Never mind, answer is correct. Students, let's do part 2. In part 2, to find out the number whose logarithm is given, as the number is less than 1, so therefore we use a little different technique when we are using calculator, as in part 1 we used. We let the required number be y, which is unknown, so log y is equal to 1 bar 0.7427. Taking antilog of both sides, we have y is equal to antilog 1 bar 0.7427. If you recall the definition of logarithm, we know that the logarithm is the sum of characteristics and mantissa. Here we have the same phenomena for anti-logarithm. 1 bar is characteristics and 0.7427 is mantissa. For using scientific calculator, we first separate them, as calculator do not understand what is 1 bar. It is not fed into it, so therefore we write as anti-log 1 bar plus 0.7427. We put bracket over here. Antilog, we write minus 1 plus 0.7427. As we know that 1 bar can be written as minus. Now we use scientific calculator to find that value. Like, if logarithm of the required number is smaller than 1, that is, it is negative, or its characteristics written is bar, as we are doing such a question in which we are required the number whose logarithm is 1 bar 0.7427. In that case, we use the antilog function in such a way that we are doing now. We press the shift button first and then press the log to activate the antilog function. Now we put the value as left bracket minus 1 plus 0.7427 bracket close by right bracket, and then we press equal. We get 0.552968005 on display screen. As we know that in anti-logarithm tables, we have to restrict that value up to first four significant digits. When we round these, the value will become 0.5530. 0.5530. These extra digits are removed by the rounding process, and hence we know the unknown number y 0.5530 whose logarithm is 1 bar 0.7427. That's it for this question. Thank you.